laser pointer?
So the laser is going to be the red dot right there.
Cool. Thank you very much. Good morning, everybody. This is Sagar from Boxologic. I'm the founder and CEO of the company. So we are an e-commerce company in the field of e-commerce fulfillment robotics. So, and let me start the presentation now. So first of all, we try to answer the question, why now? Because the e-commerce is booming, as you see. As of 2017, it's $2.3 trillion, and in US, only 8.1% is online, meaning there's a huge room to growth. So there's a problem in the e-commerce shipping industry. As you know, there's a DIM charges called dimensional weight charges. And this is the actual case. The case is 11-inch cube, and its actual weight is 1.5 pounds. But because of the DIM charges, you are paying 10, like it's a 10 pounds item, which is huge. And almost all of us receive such boxes, right, in Amazon, a tiny item in a relatively big box, which is unavoidable, unfortunately. And Amazon has 85 different boxes, still creates a lot of void space in their boxes. So if you have 40% void space, which is the industry average, which is a huge number, we have the source for it too, you are increasing your corrugated use 15%, your void filler 60%, and most important, your transportation costs 20%. And we are talking about 6 billion boxes in US only, and 28 billion boxes in globally, just for e-commerce as of 2017. So the solution is you have to eliminate the void space because you are paying for air. Air is free until you ship it. But in this case, if you have a huge box, you are paying for it, you don't need it. So for that reason, there's a concept called box on demand. It's you will start from a fan-fold corrugated, to a full box within 20 seconds. So less is better, of course. So it's a machine which is on-site. It creates instantly the right size package based on the dimensional data you provided through your WMS or through 3D scanning. So this is the very conventional way of building a box using box-on-demand solutions. So you start with a fan-fold corrugated. Oh, sorry. You start from a fan-fold corrugated. There is a cutout pattern. You do the slotting, trimming, you do the line scoring, you do the folding and gluing, and then you got a flat case. Then still you have to form it, bottom seal it, and then you fill it in, top seal it. That's the very basic process of doing this job. So, and right now there are 6 competitors in the market, and they all use the same methodology. And if you have such a methodology, you have to have a huge machine, an incredibly big machine, 200 square feet, sometimes 500 square feet. You can live in it with your family if you like to. And you have to create a lot of trim leftover. You can't avoid it because of this methodology. So what we have done is a patent pending methodology, which is completely different than this. And we can create the smallest machine in the world with lowest waste rate. For example, this is one solution provider, CMC machine. As you can see, it's a huge machine, first of all. And it uses only one type of corrugated to create any size of box. You feed in the corrugated material, and then you feed your shipping items from here. It wraps it around and gives you a full box. Those machines are, first of all, very big, as you can see, and very expensive too, $700,000 to $1 million. That's a great number. Or like a pack size, this company can give you it can support up to 4 different SKU of corrugated because they want to reduce the trim leftover. The trim leftover is a huge issue in this field. But it gives you but it gives you a flat corrugated like this, and then still someone has manually formed it and bottom seal it. Or like this. Those are all different solutions, but they all use the same methodology. So, and this is your packaging environment. So with those big machines, you can't get anywhere closer to this process. You have to put your machine somewhere else, produce the boxes, and then you have to deliver to the packing stations, which is incredible. And this is our solution. The smallest machine in the world is just 50 square feet compared to 200 square feet industry average. And we can produce, with the entry-level machine, 20-inch cube to 6-inch cube and any size in between. And we are using only one type of corrugated to create any size of box with the lowest waste rate. It's very critical. If you use only one type of corrugated to create big boxes or small boxes, we are giving a lot of trim leftover. In our system, we are using only one SKU of corrugated and creating still the lowest waste rate, which is 1/7 of the industry average, not half, it's 1/7. And in between, the corrugated comes in from here, and you got the fully formed bottom sealed box from this opening, and there is no human intervention in between. And this is clusterable. This is very critical, because when you cluster our machines, you can even produce a box within 1 second. Then, because the process capacity will increase. I can give you the details in our desks in the later stages. And plug and play, meaning that it's like a copier machine. When you receive it, you don't need any integration there. You just take it, you get the dimensional data either from your WMS or from your own scanning system, and then you can start building boxes. We don't need to even send in a technician. And we have different business models. I will talk about it too. This is a very typical setup, but we have a lot of different setups based on your process, so we need to observe it if you are interested, of course. So here is a machine. You got your items for order picking cart or pot wall. You take the item like this. Box comes from here. You fill it in and push it into the conveyor. We have different models which has top sealing and labeling applications too. So this is the competition. As you can see here, they are huge. This machine is 500 square feet, over 500 square feet. It creates 10 times more trim leftover than us. It uses only 1 SKU of corrugate, no operator required. CMC, 113 square feet, 10 times more trim leftover. Panotech, 2 operators, 177 square feet. Sealed, which is only US company, 125, 1 operator. This company is a UK company, Lenkex, pack size, 1 operator, 200 square feet. And this is us. Smallest machine, same throughput, no human intervention, and lowest waste rate. So the trim leftover, let me show you something. So this is an Amazon box, right? When you unfold it and use a box on demand solution, this is the trim leftover you are creating. Excuse me. This is a waste. In our system, this is our trim leftover. It's a huge difference. And, sorry. As you can see here, per ton is $1,500, but trim leftover is only $70. So if you are using single SKU of corrugated to create any size of box, you are creating 10 times more trim leftover than us. If you are using multi-SKU corrugated, you are creating 5 times more trim leftover than us. It's not just the economic value of it. You have to compact it. You have to do the inbound logistics. You have to do the storage, and you have to send it to your recycling center, which is huge. Carbon footprint. Nobody cares about this page, unfortunately. Thanks to God's side, it's caring about it. So in our system, the competition creates 0.18 pounds per box. We are creating only 0.07. That's a big difference, too. So in their system, they are using a lot of different SKU of corrugated, as you can see here, because they want to reduce the trim leftover. For example, this machine can support up to 12 different SKU of corrugated. It's the same as well with the pack size. We are using only 1 for any size of box, again, with the lowest waste rate. So this is our keynote page. So first of all, we are eliminating the void space. Only 1 SKU of corrugated, again. Only 1 SKU of corrugated, reduction in corrugated use, void filler, transportation cost, lowest waste rate, smallest machine, lowest carbon footprint, only clusterable machine in the market, and highest throughput per square feet per year. The closest competition is $2,000 per square feet per year. And this is the bottom line. We have a very detailed value engineering model behind it. When you go with precise stack box versus Boxologic, your throughput is 300 versus 450. Your annual savings is $250,000. Per box, if your average shipping cost is $5, $1.6 versus 77 cents. And return on investment is, again, 10 months. And we have a very detailed model behind it. We can show it to anyone interested. Who is our customer? Anyone requires random size boxes and process more than 40,000 boxes per month. We have different models. We can skip that part for now because I believe we have some limited times here. And those companies we are in discussion with them. They are all expecting a test-ready machine. We are an early-stage startup, so we look funding for creating our test-ready machine. We are in VP-level discussion with those guys. Yep, that's it for now. If you have questions, please go ahead.
Excellent. Thank you very much. Round of applause.
Thank you.